In this chapter, we're going to dive into the idea of software reuse. Now, this isn't just some abstract concept. It's a principle that's absolutely fundamental to how modern software gets built. We'll look at how we can cleverly leverage existing pieces of software to build brand new systems faster, more reliably, and of course, more cost-effectively. Trust me, this is a practice you're going to see and use every single day in your career.
Think about it like this. When an architect designs a massive skyscraper, do they reinvent the steel beam? Do they figure out a new way to make windows or elevators for every single project? Of course not. They use standardized, prefabricated parts that are known for their reliability and efficiency. Well, software engineering is pretty much the same deal. Reuse-based development is all about intelligently assembling these existing, proven components, and they can be anything from a small function to an entire system, instead of writing every last line of code from the ground up.
So here's our game plan. We're going to start with the big why. Why does reuse matter so much? Then we'll map out what's called the reuse landscape so you can see all the different forms it can take. After that, we'll zoom in on three major strategies: application frameworks, software product lines, and reusing entire application systems. And then we'll bring it all home with a quick summary and some final thoughts.
All right, let's kick things off with the most basic question. Why has software reuse become such a cornerstone of modern development? Well, the answer is pretty simple. The industry demands it. There's this constant pressure on development teams to deliver really high-quality, super complex software, but to do it faster and cheaper. And it turns out reuse is one of the most powerful ways to actually meet those demands. When you look at the benefits here, you can see they're pretty wide-ranging. It's not just about saving a few bucks. For starters, accelerated development is a massive competitive advantage. Getting your product out the door faster is everything. This also leads to increased dependability. I mean, if you're using components that have been battle-tested in a dozen other systems, you know most of the bugs have already been found and fixed. That, in turn, reduces your project risk. It's way easier for a project manager to estimate costs and timelines when they're working with known pieces. And finally, reuse helps you stick to standards, which is especially important for things like user interfaces. You get a consistent look and feel, and that makes for a much better user experience.
But, it's not all sunshine and roses. Reuse isn't a silver bullet. It comes with its own set of challenges. For one, actually creating and maintaining a good, high-quality library of reusable parts, that costs money and time. It's a real investment. Then there's the work for developers to find the right component, figure out how it works, and then adapt it for what they need. And maintenance. This is a big one. What happens if you're using a component and you don't have the source code? If a bug pops up, you're totally at the mercy of the original creator. And let's not forget the human factor, the classic not invented here syndrome. Sometimes engineers just have a natural resistance to using someone else's code. They'd rather build it themselves.
Okay, so now that we've got a handle on the pros and cons, let's explore what we call the reuse landscape. You can think of this like a map of all the different ways you can actually implement reuse. It's not a one-size-fits-all kind of thing. It happens at a bunch of different scales and levels. So reuse exists on this whole spectrum. At the very top, you have system reuse. We're talking about reusing entire applications inside a bigger system. A step down from that is application reuse. Maybe you incorporate a whole program into your project. Then you get to component reuse, which is super common. Think about using a pre-built login service or a payment gateway. At an even smaller scale, there's object and function reuse. The classic example here is just using a math library or a graphics library. And finally, there's one that I think is really interesting: concept reuse. Here, you're not actually reusing any code. You're reusing an idea, like a famous design pattern or a proven algorithm, and you're the one who implements it. So with all these choices, how in the world do you decide what's right for your project? Well, you've got to weigh a few key factors. How tight is your schedule? If you're in a rush, maybe reusing a whole system makes the most sense. What's the expected life of the software? For something that needs to last for years, you have to be careful about reusing parts where you don't control the source code. What about your team's skills? It's usually a good idea to stick with technologies they already know inside and out. How critical is the software? If it's a safety-critical system, every single component has to be rock solid and verifiable. And of course, the kind of application you're building and the platform you're targeting will have a huge say in what's even available for you to reuse. All right, let's dive into our first major reuse strategy: the application framework. The best way to think of a framework is like a reusable, half-finished application, kind of like a software skeleton. It gives you the generic structure and a bunch of built-in features, and then your job, as the developer, is to fill in the specific bits and pieces to create your final product. Now, here's the more textbook definition. A framework is an integrated set of software artifacts that collaborate to provide a reusable architecture for a family of related applications. That word right there, architecture, is the key. A framework isn't just a library of functions you can call whenever you feel like it. No, it defines the entire structure and the flow of your application, and you have to build inside of that structure.
A super common architecture for frameworks, especially if you're doing any web development, is the Model View Controller Pattern, or MVC. And it's popular for a reason. It neatly separates your application into 3 distinct parts. The model, that's all about your data and your business rules. The view is what the user actually sees and interacts with, the user interface. And then the controller is the middleman. It takes user input and tells the model what to do or the view what to update. This separation just makes the whole system way easier to build, to test, and, most importantly, to reuse.
This brings us to a really, really important question when you're working with frameworks. See, in traditional programming, your code is the boss. It calls library functions when it needs them. But with frameworks, that relationship gets completely flipped on its head. So who's actually in control? The answer is a core design principle called inversion of control. In traditional programming, your code is in charge. It dictates the entire flow. But with a framework, this is inverted. The framework itself is running the show. It controls the program's flow, and it's the framework that decides when to call your code, not the other way around. Your code just gets plugged into the framework at specific spots. People often call this the Hollywood principle. Don't call us, we'll call you.
Let me make that a little more concrete. Imagine a user clicks a button in an app that's built with a framework. Okay, so first, the framework's event loop, which is just always running in the background, detects that click. Second, the framework knows that a click on that button is tied to a specific hook method, basically a placeholder for your code. And finally, the framework calls that hook, which then runs the specific piece of code you wrote to handle the click. See? You don't manage the event loop, you just supply the code that gets called.
Okay, our next big strategy is the software product line. This approach is incredibly powerful for companies that has to build and maintain not just one application, but a whole family of similar ones. Think of a printer company, for example. They might have dozens of different models, right? They're not writing the control software from scratch for every single one. They use a product line.
Now, it can be a little easy to mix up frameworks and product lines, so let's be clear on the difference. With frameworks, you typically extend them using object-oriented things, like inheritance, and you generally try not to mess with the framework's core code. Product lines are often more flexible. You might directly modify, rewrite, or even replace components to fit a new product. Frameworks also tend to be more general purpose, like a web framework, while product lines have really specific domain knowledge baked right in, like the details of a medical record system. So the short version is you extend a framework, but you configure and adapt a product line. Let's look at a quick example. Imagine a software product line for an emergency vehicle dispatch system. You could adapt it for police, fire, or ambulance services. The core architecture might have these 4 layers. At the very bottom, you have database management for all your data. On top of that, the resource management layer has the core logic. It tracks vehicles, logs incidents, and handles dispatching. Above that, I/O management handles things like authentication and reporting. And at the very top, the interaction layer is the UI for the operator. Now, if you wanted to create a version for the fire department, you might tweak the vehicle database and the resource management rules for different fire trucks, but you'd get to reuse all the other layers.
All right, now we're moving up to the highest level of reuse, reusing entire application systems. At this scale, the focus shifts away from writing code and moves towards configuring and integrating huge pre-built software packages. You'll often hear these called commercial off-the-shelf or COTS systems.
This approach usually comes in 2 main flavors. On one side, you have configurable application systems. This is where you take a single massive product, like an ERP system, and you just configure it for your specific customer. The work is all about configuration. On the other side, you have application system integration. This is where you take several different systems, maybe from different companies, and you build the glue that connects them all together into a new custom solution. In that case, the focus is all about integration, making sure these separate systems can talk to each other.
The classic example of a big configurable system is an enterprise resource planning system, or ERP. Think of companies like SAP or Oracle. An ERP is just this enormous, integrated suite of software that supports almost all of a big company's main business functions: purchasing, supply chain, CRM, you name it. And it's all built around a single massive database. Companies don't build these things, they buy an ERP and then spend months, sometimes years, just configuring it to match their unique business processes. Now for an integration story. Let's say a company needs a new procurement system. They decide to connect a modern, web-based e-commerce platform with their old-school legacy ordering system. The problem? These two systems were never, ever designed to work together. They probably use different data formats, different ways of communicating. Everything is different. The solution is to build what's called an adapter. It's a piece of software that sits in the middle, translating requests and data back and forth so the two systems can talk to each other without even knowing they're different.
This example really shines a light on the big challenges of system integration. The main thing is you have a serious lack of control. The vendor's product might be buggy or slow, and you can't just jump into the source code and fix it. Also, vendors update their products on their own schedule. A new version of one part could totally break your integration. This all leads to a heavy dependence on those vendors for support, which can become a huge business risk if that support isn't there when you need it most.
All right, we've covered a lot of ground. Let's wrap things up by quickly recapping the key ideas we've talked about. So, what are the main takeaways here? First, remember that reuse is a big concept covering everything from tiny functions to massive systems. Second, application frameworks give you that reusable skeleton for your app, and they're built on that key idea of inversion of control. Third, software product lines are the strategic way to go when you need to build and manage a whole family of similar applications. Fourth, application system reuse, whether you're configuring or integrating systems like ERPs, is how a lot of big business software gets made today. And finally, and this is probably the most important point, there's no perfect solution. Every one of these strategies comes with a trade-off between some really powerful benefits and some pretty significant challenges that you have to manage.
I want to leave you with one final thought. We've talked about a lot of technical stuff, frameworks, product lines, integration, but in the real world, the success of a reuse strategy often comes down to something else entirely. It requires a major shift in how an organization even thinks about building software. It's about changing processes, it's about encouraging sharing, and it's about building a culture where people value leveraging existing work more than they value reinventing the wheel. And that, at the end of the day, is a human challenge, not just a technical one.